started. So today's goal is to build a chatbot, small chatbot that shows what you can do with machine learning and how you can train a chatbot just using machine learning and not rule-based systems. So we're going to do this with Rasa NLU and Rasa Core. But first, a bit of a motivation, like why do we actually want to build a chatbot? So here's an example conversation. The user talking to a bank, like a bank chatbot, and he tells the chatbot that he just moved, right? So the bank has the address stored, and so they want to update the address, right? So they want to keep that on file, and the user just provides a partial address, and the bot suggests it's in New York, right? Which is not correct. The user thinks, or doesn't think, he lives in San Francisco, and he corrects that answer from the bot. And from that interaction, you can see that even this simple interaction of filling one form field with a new address can be quite different between users, right? So one user might write that address right there, completely correct in one message. Other users might use multiple messages, only put the street there, only put the city there, or I don't know, misspell something, right? And so you need a chatbot that actually is able to handle these different users and this different dialogue flows. And what we see here is that conversational AI will dramatically change how your users interact with you, because it's quite different from an app UI or from a web page, because here the user defines how the conversation continues, right? In your app or on your web page, you define the layout, you define the menus, right? So in this way, with a chatbot, the user decides what happens next, and the bot reacts. And if the user provides different input, he will follow a different flow. And the goal is to build a small example that shows that different user inputs can actually influence the bot and how that translates into a machine learning model. And as I said, we're going to use Rasa. It's an open source framework, so it's two parts. It's Rasa NLU and Rasa Core, and I'm going to explain in quite some detail what they are about. So there's a lot of machine learning going on there in both parts, and we'll see how they connect and how they form a bot when combined. There are a lot of other solutions as well, but we're one of the only major open source solutions that do dialogue handling. All right, so here's a major, here's a high-level overview over the solutions. So the user message comes in, what's the weather like tomorrow? This usually goes through a connector, right? Could be Facebook, could be WhatsApp, or just a chat window on your web page. And that message then gets forwarded to your input module. This is so-called NLU, right? So you want to understand the message of the user, right? It's just typed text, and now we want to extract information from that. What does the user mean with that message? Which information is part of that message? This is what we call input modules. Then we have our dialogue management here, which we call a brain. So the brain gets all the structured input from the NLU and is connected to the backend databases and APIs, right? So it's able to fetch more information from the web, like weather APIs or your backend or database, and combine that information with the dialogue it's having with the user. And the third part are output modules, right? So when we've found the answer that we want to return to the user, we still need to create some text for the user to understand. So because from APIs we usually get structured information again, so now we need to convert that into sentences again that the user can understand. And in our example, it will be sunny and 20 degrees after the user asks what's the weather like tomorrow. And that information obviously required us to call an API to get the sunny and 20 degrees. It required us to figure out that there's tomorrow in there. And as you might see, we didn't ask for a location in that sentence. So we either got it through GPS, or we have it from a past conversation, or we got it from the database because it's the usual location of the user. But you could imagine that for new users, we don't know the location, so the dialogue would go into a different direction. Here are a couple of alternatives, right? So there's Dialogflow, which is a hosted solution from Google. They do mostly NLU and a bit of rule-based dialogue handling, so you can do some form filling and I think they call it fulfillment, so calling APIs. Then there's vidAI, which is from Facebook, and then there's Luis, which is the last one, and that one is from Microsoft. All of these are hosted solutions to kind of have UI and build it online. We focus on a bit of a different area. So why would you want to choose Rasa over these hosted solutions? It runs locally, right? So you can just spin it up locally. You have all the control over your instance. And you can also deploy it anywhere, right? You can run it locally, you can run it in the cloud, you can run 100 instances of it in parallel to scale your load. And most importantly, you own your data, right? So none of your data is gets sent to a central server and stored at the Google headquarters, which is especially important for sensitive data like health information or banking information and all that stuff. And it's hackable, right? So you can actually create your own machine learning models. We provide a couple of them. We provide dialogue models. We provide models for NLU. But in the end, if you decide, okay, this model, I outgrew that model, I have a lot of data, I can analyze it, and I do have some insights into what might work better, and you can just create your own models and plug them into Rasa, and your system will still work using your own models, so you can further improve down the road when you've collected more and more data. All right, couple of words about me. So I studied computer science in Germany, and then I went on to found a consultancy focusing on image and text analysis called Scalable Minds. And then my interest in text and messages and analysis brought me to the Rasa team, where I'm now leading the open source development. So all the parts we're going to see, the Rasa Core, Rasa NLU, that are open source on GitHub, leading the development there. And yeah, if you have any questions about that right now or later, or when you try it out at home, just let me know, shoot me a mail, or we have a GitHub channel as well. So if you need any support, just let me know. Yeah, that's about me, but I also want to get an impression of you guys. So who of you has already trained a machine learning model? Oh, that's a bad one because there was talk about that. So who of you has worked with natural language processing before? Like text processing, cool. Who of you has already built a chatbot? It's getting thin. Who of you has used Rasa? That's good. All right, because now I can explain it to everyone. And that's our goal, right? So we want to build a bot that's able to understand natural language in a certain domain and that can handle certain types of user input. Here's a quick roadmap of how we're going to do that. So first we'll focus on natural language understanding. So as I said, getting user messages in and transforming them into structured output. Some theory there, and then we're going to code a bit. Then we're going to have a look at dialogue handling. Again, some theory, some coding, and at the end, I also want to have a look at some research we're currently doing. So just telling you about different topics, different areas we're currently looking into improving models. And there's probably some time at the end for questions, but if you have questions in the meantime, just let me know, raise your hand, and then we'll tackle them right away. Okay, quick setup. So as I said, we're going to use not Jupyter, there's an H, doesn't matter, Jupyter notebooks and 3.6, so you should have that installed if you want to run it locally. Otherwise, I'm going to run it here as well, so you could just watch me as well. But it's also fun to try locally and play around with the bot you're creating. And as I said, that's the URL, same one as here. All right, so let's take a look under the hood of the natural language understanding. Right, so our goal is to create structured data. So this is another example. User says, I have a new address, it's 709 King Street in San Francisco. And there's two things we want to know. First, what is the user trying to tell us in general, which in this case is address change. Right, so this is the overall intent of the message. Could be a greeting as well, it could be a goodbye, it could be I want some information about my account. Right, there's a lot of different categories, but in this case it would be address change. And once we've found that intent, we still need some additional information to change the address in that case. Right, these couple words, 709 King Street, San Francisco, that tell us the address of the user to actually change our data in the database. And one step further, we not only need to extract that information, we also need to normalize it. It's especially important for these addresses or for dates or numbers. You don't want to have the word 3 or 4 as a text, but you usually want to have that as a number when you want to handle that in code or write that into any database. So that's one big part as well. But let's take a look at how that works. We're going to look at the intent classification first. So our user input is now, what's the weather like tomorrow? And that hits our natural language understanding component and gets now classified. Right? And to do so, we first vectorize our input sentence. So we have the different words, what's the weather like tomorrow? Each word has a vector. We'll take a look at that later and see how Spacey provides these pre-trained word vectors. And then you need to combine these word vectors into a sentence representation, right? Same vector, I don't know, 300 dimensional. And that word vector representation of the whole sentence is then fed into an intent classifier, right? Simplest case is just an SVM that you run and train on a couple classes. And in this case, our output will then be request weather. And here's a really, really simple approach to get a sentence representation. So we have our message, we have our bag of words, right? So we split the sentence into its tokens. So simplest way is to split on white space. But as you can see, even with the what's, you need to put in some logic there. But it's kind of 99% solved. And then you have your bag of words, and you look up the vector for each of that word, of these words, and then you can just combine them with an average, right? This is the so-called bag of words approach. Order doesn't matter, right? So if we reorder the words in the sentence, the model doesn't care, which also brings us to a downside of that model, because of course some meaning gets lost in that process. But for simple chatbots, that's usually fine. But once you've collected more data, you should probably use a more advanced model. And then we can feed that into our SVM and start a classification. In that case, we have, 5 classes. So greet, goodbye, thank you, request weather, and confirm. And as you can see, the classifier will put every message into one of these buckets, right? So every incoming message is either greet or one of the other 4, right? If we put in I want a pizza, it will still be one of these 5, right? So this is something you need to keep in mind, that the bot has a limited view of the world, especially if you use that approach. There are other approaches, but that one is particularly good when you get started because it's a simple model, it's an SVM, it doesn't need too much training data to do reasonably well on a small data set. All right, let's take a quick look at the entity extraction as well. So that's a bit more complicated, but very similar. So we tokenize the sentence as well, again on white space, for example. Then we use a part of speech tagger that is not necessary, but provides some useful information. So in that case, we would tag what is the verb, what is the adjective, what are how the dependencies look between the words, which gives us some more information about the structure of the sentence that we can later use for classification. Then we have a chunker to form larger chunks of words. For that sentence, that's not really necessary, but for the one with the address, right, we have that address, which is multiple tokens, but kind of one chunk. And then we do our named entity recognition and extraction. In our example, we would have the input, what's the weather like tomorrow, and the output would be, okay, the value is tomorrow, and the entity type we extracted is a date. As you can see, we still haven't normalized that, so it's still tomorrow, and we probably would want to get that into a proper ISO date. Here's a possible model you could use, right? So where can I get a burrito in the second arrondissement? There are two entities here, cuisine and location, and there are multiple ways to do this classification task, right? As I said, we first tokenize the message, and then we can, for example, use two classifiers. First one just saying, okay, is this token an entity? And the second one, okay, for the ones where we found out there's an entity here, which type of entity is it? Right, we could do it that way. Does work, okay, not really well. Better is a direct structured prediction, where you go through the sentence, look at each token after one another, and the prediction of the current token is influenced by the surrounding words, right? Because it is more likely in our street case, where in the middle word, maybe San Francisco, is tagged with a city, that the surrounding token is an address, right? So the words influence each other, and using, for example, a conditional random field, as we do in Rasa, is quite a good solution, or one good solution that works with few data samples. As said, you can then expand that and use, for example, deep learning models, embedding character embeddings to then train DNAR models. All right, let's code. So here is what we want to build. It's a quick little thing. So the user says hello, bot answers hello, and then asks, okay, how are you? In this case, as you can see, the Facebook UI can even provide a couple buttons, but you can actually write whatever you want. That's the idea. And then the bot responds with an answer. In the case where you are sad, bot tries to lighten your mood. And in the case where you're already feeling great, the bot is doing something else. And this is what I mean with like forking the conversation, right? Depending on the user input, we're going to do different things. It's a really simple example, but as you can imagine, this is how it works for the address case as well. But restricts the domain a bit and makes it a bit easier for us to code in such a limited time. All right, so let's jump into that IPython notebook. Here we go. Okay, let's not show all of that here. Okay, cool. All right, so I'm just gonna step through these different cells. There's a bit of code that's already in there, which is mostly setup code. I should make it bigger, probably. All right, yeah, that's good, I guess. So first, yeah, we're gonna set up matplotlib and a bit of logging and a small helper that allows us to predict. It's a bit easier. And then there's this block of setup. So it actually installs 3 packages: Rasa Core right here, Rasa NLU, and as part of Rasa NLU, it installs Spacey as well. So yeah, I'm going to run that as well, but I actually have that installed, so it shouldn't actually do anything but download the model. So yeah, it takes a minute. Yeah, you can either run it here in the IPython, or you can also run these commands on the command line in your environment, installing like these dependencies. That Spacey model we're going to use is trained on a web crawl, right? So a couple web pages that got dumped into a large file, as well as I think telephone records from telephone companies, which is pretty cool for us because they are quite relevant for the chat domain, because shorter messages spoken and not written, and yeah, and I don't think the Wikipedia is in part of that one, but yeah, it's quite a solid model. Spacey actually provides a couple of them, so there's a small one, a medium one, and a large one. for chatbot development, you should always at least use the medium one if you want to use Spacey, because the small one does behave a bit strange because it doesn't actually store word vectors, but actually uses some similarity to figure out the vectors, which doesn't work very well for this use case. It works better for larger documents. So that's why we're going to use that medium model. Yeah. Okay, getting close. Yeah, we also provide a new pipeline in Rasa NLU that doesn't actually use Spacey, but uses a different approach to word vectors. So there you don't need like these pre-trained word vector models. But in our case, because we do have quite a small data set, it's better to use these pre-trained word vectors than to start from scratch. Who of you already knows about word vectors? Not that I'm like talking about something that no one. Okay, that's good. So kind of you have your bag of words, all the words you know, and you assign a word vector to each of them, like, and that word vector should somehow capture the meaning of that word. So that's like a rough explanation of how they work. But yeah, there's a lot of blog posts about that as well. So what we're going to do next is just test that our installation is as I expected it to be, and you should have Rasa NLU 12 and Rasa Core 9, and that Spacey model should load properly. Right, it's looking good. We also need GraphViz and the PyGraphViz package for some graph we're going to plot later. If that doesn't work on your local machine, it's not. Don't worry about that. I'll show the graph here as well, and you can install it later as well. Cool. Okay, let's. Yeah. Okay, that's good. All right. So let's start like creating training data for our model. So how this works in Rasa is you have a file and then you put in the intents you want. Like in this case, I want the intent greet. And now I need to specify examples for that, right? So one example could be hi, another one could be hello, then we could have like good morning, or a good day, or a good evening, or howdy, right? You get the gist. Then we need a goodbye as well, so that our user, our bot knows when to say goodbye. See you. Goodbye. Yeah, it's always sometimes also good to include some spelling mistakes because users are going to do that. As I said, Rasa is modular, so what you could do as well is plug in some component before Rasa NLU that actually does some spell checking to make some of the models more robust against like these typing errors. I'm a bit lazy, so I'm just going to copy a couple of them. All right. So as you can see, still greet and goodbye as two intents. Then I added some more examples for mood affirm. So when the user says yes or indeed, it kind of affirms the action of the bot, and then some examples for deny. So if the user like denies what the bot is doing, and then for our mood bot, where we want to like ask the user how he's doing, we also need some examples for utterances that tell us like the mood of the user. So we have two categories: mood great and mood unhappy. My day was horrible. I'm sad. So yeah. I hope your day is more like the examples in mood great. And we're going to write them to a file. And this file is then going to use for the training. We're going to modify that later as well, but this is our initial version.
Good question.
Yeah,
That's
go ahead.
I guess
That's part of a notebook. Yeah, so it's a pretty easy way to write a variable to a file. Yeah, yeah. I think it's built in. I haven't installed anything, hopefully. Yeah, so it's pretty. So we need all the data in files because that's usually how you run these trainings. The idea being that you collect more and more data over time, store it in a database or on disk, and then load it in a script. We provide a couple scripts to really train the models on the command line. But in our example, we're not going to do it, but we're actually going to do it in Python code. But you can also, yeah, there's tutorials on the documentation, so you can find that. The links are in the slides as well. You can find the documentation under nlu.rasa.com. And there's a couple examples that show you how to train the models even without Python, to get started really quick. But as said, we're going to do it in Python because it's cool. All right. As I said, Rasa NLU uses components to do the classification. So we do have different components for different tasks that allow us to exchange them in our system and replace them with better components for our task at hand. We do have one component for Spacy here that loads our Spacy language model. So this kind of loads the language file, puts all of the vectors into memory, and then when a message is coming in, assigns these vectors to our message. And we have a tokenizer Spacy. So Spacy also provides tokenization. Oh, I don't want to have that in here yet. Then we have our intent featureizer Spacy. So this is doing the mapping from one word to one vector, and from a couple of words, so a sentence, into one vector for that sentence. So this is our intent featureizer. And at the end, we have our intent classifier sklearn. So in this example, it's an SVM in that class, but yeah, you can replace it with any other classifier from sklearn that you want to try out. All right, so let's store that in the configuration file as well. Oh yeah, let's take a quick look at how these components work. So they get the context, which is kind of the training data. Then the first component in the pipeline gets created and initialized, and the second component in the pipeline gets created and initialized, and the last component and so on. And once all components got created, they get trained after one another. And this allows us to really push data from one component to another, right? So one component that comes later in the pipeline can use the information a component previous in the pipeline provides, which you usually want if you create these vectorizations or tokenizations. And then all of them get persisted. So this is kind of the training life cycle, but the same happens when we actually handle messages. There is a similar flow. All right, so let's actually train our model. So we've created our configuration. We've created our training data. Yep.
So I'm not familiar with Spacy. Could you give a few examples of these tokens? Are they like word embeddings or is it something else?
The tokens?
Yeah.
So tokens is really just single words, right? So if you have a sentence,
Like the white space.
exactly, splitting on white space, you usually get most of the tokens, but then again, you sometimes have what's, with what and an apostrophe s. Don't have a white space, there are still two tokens. But yeah, splitting on white space is kind of a good approximation in the beginning, but you can train to be better. Yeah, so yeah, one part tokenization and then assigning each of these tokens its vector is kind of what Spacy does. Okay, let's take a look at the training code. So it's quite simple. So we load our data, which is the intents and examples we've written into the file. Then we create our trainer based on our configuration. So it's creating this pipeline up here. And then we can actually train the model. And we'll get back an interpreter we can actually use to parse messages. And because we need to use it later on with our dialogue model, we're also going to persist that to the model's NLU folder. yeah, what you can see is that we have like 6 distinct intents in our domain. A couple examples, and no entities right now. So as you've seen, I didn't add any entities yet. We're going to try that out in a minute. And then one component after another gets trained and then persisted to disk. Okay, what about entities? That's a good question in my notebook. So for intents, you usually don't need too much training data. For simple domains where the intents are quite different, like goodbye and hello, right? Words are quite different, so it's quite easy for the model to pick up different intents. For entities, it's a bit harder. So usually you need a bit more training data. That's why this example doesn't use any entities later. But we're still gonna try to add some entity recognition here. So hey, I am Tom. Hello there, I am Thomas. And usually how you would annotate entities in Rasa is just writing it like that. Right, so the entity value in brackets, and then we're gonna annotate that. Alright, cool. And we don't have any entity recognition component in here. I can just add that. All of these components kind of come with Rasa NLU when you install that, but as I said, you can always write your own ones.
Question that.
Yep.
The training set you have to put the entity where you define an intent. So actually, an entity is a part of the text that defines an intent.
Yeah. Yeah.
Not
But
standalone.
so yeah, the entity is always defined in these samples, right? Because you want to detect it in the samples, but it is not the entity type. So person is not bound to greet. So you can still recognize a person down here in a goodbye example. Obviously, if the model has never seen that in a goodbye example, it usually won't pick that up. But entities and intents are kind of separate concepts. Like there's like not this concept of these are the 5 entities that belong to this intent or something like that. So they're kind of separate. So kind of every entity type can occur in every intent.
So what's the good practice? Like you define the entity once in one random intent and then will be picked up in all the other intents, or define it everywhere?
I mean, you should label it across intents. So it's better to label it across intents than just in one intent, because what the model will pick up is sentence structure, right? So it will also recognize values it has never seen during training. So for in this case, at some point, if we have enough training data, it will pick up other names that we haven't seen in training. And to do that, it needs to like recognize the sentence structure. And for this to happen, you should like provide different sentence structures. And that means you should put it into different intents, because the entities usually occur in different places in the different intents, if that makes sense. Yeah. Right, so we could, for example, say buy from Peter or something like that. Zip person. Is that right? Yeah. Okay. All right, so I'm going to add one component here that actually does the intent recognition. That's actually a pre-trained component, so it's not training on that data, because as I said, we do need a bit more training data and not just 3 examples for entity recognition. So usually you need, I don't know, around 50 or 100 samples to like really get like a stable model there. This is why we're going to use the pre-trained model. The pre-trained spacey NER model. Alright, so just added that to the configuration. We could just try again. Right, and now we do have one entity here, right, 3 examples. And let's see how the training goes. Alright, still pretty quick. As you can see now, we've added NER spacey here as well. So that's now part of our pipeline as well. I'm not actually going to use this name part of the model, but for the sake of showing intents. entities. That's a good way. All right, so in this step, we can actually try the model out, right? So now that we've trained it, we can actually shoot messages at it and just play around with it and see how it performs. And as you can see, it's doing quite well for that message that I hope does not belong to the training data. Doesn't matter. But we can also shoot hello there. It's still a greeting, so quite good. Let's see. Oh, come on. Oh, that's wrong. That's probably wrong because it doesn't have a word vector in the English language, I guess. Right? In the corpus it's trained on, it probably does not have an assigned word vector, so it gets represented as all zeros, which is kind of a bad input for our machine learning model because it's just one word which has all zeros, so the whole sentence has all zeros, so there's not a lot of input for the model to pick up. Yep?
What happens if you put in the word dinosaur?
Let's put in pizza. It's a greeting, right? As I said. Or, I don't know, Hawaii. I don't know, it's goodbye, right? As I said, it will assign all of these messages to one of the intents we have. And this is something you need to keep in mind when you handle messages. There are different ways to get around that, but it is actually quite a hard problem. What you can do is you can train models that are just trained to recognize, okay, is this message part of my domain or is it not? But actually even that gets tricky quite quickly. So for example, let's imagine you have an FHQ bot, right? So your bot answers questions, and then there's certain questions the bot is not able to answer that are kind of out of scope, right? And differentiating between these questions is kind of hard and way harder than differentiating between pizza, Hawaii, and I'm great and I'm good, right? So that would be rather easy to pick out. Yeah, in total, that's not an easy problem. But the more data we have, the more we hope that we at least get low probabilities and low confidence scores for these messages. Yeah.
What happens if you add the label none to the possible intent?
None?
Yeah, so
Oh, you mean kind of
to the default fallback in PyData.
kind of no.
Basically indicating that it's out of your domain.
Kind of providing examples for that. Yeah, that works. Then you kind of train your model on your domain as well as a couple examples that are out of domain. Yeah, as I said, for these simple examples that will work. But then again, usually the messages that are in your domain are smaller than the ones that are out of domain, and then you run into issues with class imbalance and stuff like that, right? So yeah, the parts that are out of your domain are way larger than the ones you usually want to handle. So this is like, yeah, but this is one good solution that works well for bots. Because something that we usually advise as well, don't design for a user that wants to break your bot, right? If they want to write pizza to your bot that's doing banking, then they will probably want to break it. You can handle some of these cases, but you probably cannot handle all of them. But you should do some effort to handle them, nevertheless. All right, so in our example, Hawaii, we actually can see that any are spacey in action. So as I said, it's a pre-trained model. And we can have a quick look at the entities it recognizes. So it's trained on persons, on organizations, on locations, on countries, and time and date and stuff. So kind of a lot of pre-trained entities that you usually need in a lot of the domains. And I think it's trained on like large corpora, I think 1 node, 5, yeah. So it's the same corpus language model is trained on. Yeah, and if you need these entities, you should reuse them. And once you've collected enough data, then you can start training and refining them. Maybe you have names in your country that Spacey doesn't recognize in the model it's trained on, and then you can refine that model. All right. Hey, I'm Tom. Right, so and my name gets like recognized as a person here as well. So that works quite well. All right. Yeah, now that we've trained our model, we've played around with it a bit, but we actually want to see how it does in classification. And we do provide a couple tools there as well. There's a simple script here that runs through a file, collects the predictions, compares them, and then gives some evaluation. Oh yeah, that's running. Gives some evaluation about how good the model performs. In that case, as you can see, I just used the training data we've defined up there, but you can like define, or you should define test data. You should not test on your training data, as you probably all know. And if you don't define any test data, then you get really good results like that one. For our really simple model, what we can do real quick, we can, for example, what's easy? Maybe that one, mood affirm. I agree with you. That sounds good. I like that. Nice. So create a bit of a different training data set, and then we can still evaluate on that and see how our affirm intent performs on a couple different sentences we haven't seen during training. I don't know, I haven't tried it before, so we'll see. Hopefully works. Not too bad. But yeah, as I said, where is it? Well, it's actually not too bad for affirm, right? No, it's too bad. It's bad. Yeah, so as you can see, it's trained on like 4 samples. Right? You need way more data to like really create a good model there.
So in this case of hi, I am Tom, would it train on hi, I am Tom, like those word vectors, or would you train on hi, I am person, and then have like one vector for all the persons you can imagine?
So in the model we use for entity recognition, we don't actually use any word vectors. So it's trained on patterns. So it looks at first characters, is the stream uppercase, lowercase, does it contain numbers? And then it looks at the surrounding tokens. So it's kind of an n-gram model.
For the intent classification.
Yeah, there it's looking at the word vectors and all of them.
But then you generate a word vector for person and not for Tom.
No, it's actually using the word vector for Tom, which probably doesn't have a word vector in that case. So it will be 0. Yeah. We've experimented with replacing like known entities with other tokens, and it can definitely provide some improvement there. Yeah. Yeah. It depends a bit on what you want to depend on, right? So either you can make your entity recognition dependent on your intent classification, meaning that, let's say we recognize the intent is greeting, then the probability of finding a name is probably higher than in a goodbye intent. So we can influence our entity recognition. On the other hand, if we know there's a name in there, greeting is also likelier, right? So it's kind of a hand and egg problem.
Yeah.
And yeah, we were trying to get around that. Cool. All right, let's get our original training data back. Cool. Evaluation. So yeah, it doesn't look too good, which is usually a good sign that you need a bit more training data. As I said, it looks at the word vectors, and if there are a lot of words in there that the model hasn't seen during training, then it doesn't have a signal to pick up. Yeah, and we can also see the entity evaluation of that person model, and as you can see, it performs quite well. And as I said, it doesn't get trained on the data I provided, it just gets evaluated on that because it's a pre-trained model. So it doesn't actually look at the data during training. All right, so let me just quickly check if I have everything. Yep, looking good. Are there any questions like concerning NLU, training the model, evaluating? Yeah.
If you want to do this in, let's say, a different language, Dutch, you would need to make sure that all the models that are being used are also trained on Dutch terms and things.
Yeah.
More of a in general question. If you, because I'm assuming you have clients that also have this other language problem.
Yeah.
What's usually the best place to go to? Is it still Spacey, or are there other parts that you might recommend?
I mean, Spacey does provide some good language models for the major languages, English, German, Spanish, French. So they work pretty well. I think Dutch is in there as well. That's quite good. But then again, you can also use fast text vectors, for example. You can load them with Spacey. You can also write an own component that loads them directly. We've also created a component that doesn't need any word vectors at all, which like kind of solves that language problem to some extent. Because, as I said, you still need tokenization, and that can be quite language dependent. So yeah, you can like get around that problem a bit, but in the end, the more data you have, you should recreate your own word vectors. Even if you use like these pre-trained word vectors for the English language, as I said, they are trained on News Corpora and then web crawls. So they are from a different domain than we are using them on. So they contain a lot of words that we usually don't use in chats, and they are missing a lot of words that are used in chats. So the best way is to collect data and then at some point really fine-tune your own model, train your own language model with Spacey, or with any other library. Right? It's not Spacey dependent. All right, then let's jump back and take a quick look at the dialogue handling. But before that, and now I need Thomas. Because I need to get you awake again. At least I'm in a food coma, and I need your full attention for the dialogue part because it's a bit of heavy machine learning. And so we're going to do a quick wake-up game and have 3 minutes of fun. And Thomas is going to help me with that. And I need all of you to stand up. So just put your laptops on your chair and just get up, get a good stand. And find a partner, actually usually the one next to you, hopefully. I picked Thomas. All right, so quick game. Hope everyone has a partner.
Looks good.
Looks good? Okay. Everyone has exactly 4 movements, right? Hands up. Sounds good. Hands down. All right, hands left. And right. Yeah, it's a bit weird for you and us. I mean, you get the idea. You can choose them at random, but between each of your movements, you just slap your upper legs, right? So it's like that. Boop, boop, boop. Yeah, you can do it as well, right? It looks weird if I do it alone. So hands up. Right, you can find your own rhythm, right? Okay, that was easy. So now, now with your partner, we do it in the same rhythm, right?
First up.
Yeah.
First up.
First up, okay, doesn't matter. So, okay, same rhythm. We don't need to do the same thing. You do your own stuff. Don't look at me. Okay, and now, 1 second. You're missing the brain part. If, right, everyone does it at random. If you and your partner do the same stuff, you just give him a high five, right? So, but
Oh.
if we don't do the same stuff, we don't high five, right?
Oh, that's
Okay.
So 3 times.
Whatever we do.
Okay.
Okay. All right.
Start. 1, and then
Tap.
right.
Tap. No one to say stuff. All right. Now you can do whatever you want.
Okay, I go right. But then if you do the same stuff, you have to clap.
Just if you do the same stuff.
Yeah.
So okay, left. Okay. Not the same stuff.
Up. That up is good.
Yeah. All right. If you like the challenge, you can speed it up. Okay, guys. Thank you so much. Thanks, Thomas. Okay. I hope everyone got his blood flowing again. Okay, I hope everyone is like awake again. At least awake, hopefully listening now. And now we're going to look at the dialogue handling. So why do we actually need dialogue handling? And it's like one of the best images we've seen. So why do we want dialogue handling chatbots? Or do we want them? Sorry, I don't understand. Right, so you do really need context to handle dialogues. You can create simple bots that just answer FAQ questions and like one interaction, user posts a message, you answer, user posts a message, you answer. But if you don't take any context into account, your bot will seem dumb at some point. And it's just not a lot of fun. And we want to avoid state machines. I'll show you in a second why. They can be a good starter, but it's hard to maintain them over time, and it's hard to extend them over time. We don't want to use reinforcement learning right now because you need a lot of data there. We've tried it, and usually for the systems that chatbots are designed for, you don't have enough data for them to properly train a reinforcement learning client. So yeah, what you could do is you could write your own client that kind of simulates a chat user, but then again, what is the purpose of that? And then you need to find a proper reward function. So yeah, let's avoid that for now, and we'll use a deep learning model and a recurrent neural network. So what we want to provide is a simple solution that works. So why machine learning? So this is a simple graph, right? So user input could be goodbye, could be greet, and then bot does one action and the conversation is kind of over, right? And the next user input, next bot action. So the bot actions are always these bubbles, and these blue boxes are the intents. As you can see, these are really short conversations and really simple. But once you've started with that system and then you collect more and more data and see how users use your bot, it kind of ends up in that. So you have a lot of different dialogue paths, a lot of different actions, and they kind of like go all over the place. And as you can see, creating that as a state machine is kind of hard. And yeah, this is a really simple bot. It's not a hard one. I think it has like 1 or 2 use cases. So 1 of 2 things it can do. Yeah. All right, so how are we going to do the dialogue handling? So in this case, user message comes in, right? We got our intents, we got our entities. Let's say we figured that out. We've trained a good model, not the one we just had, but really a good one that recognizes intents and entities. And now we're going to combine it with some state. And that state is formed by the previous bot action as well as the past dialogue. And then we're going to predict the next action. So that's pretty easy. And the magic actually happens in that ecoscience. So that is our classifier, that's our SVM, our recurrent neural network, or whatever classifier you want to use. And then the magic continues, right? So we update our internal state based on that past action and the new message that we just handled. And we can create our response for our bot. So in that case, it will be sunny and 20 degrees. And probably in that case, this action we just chose called some API, got some result in the back end, and then created this response from all of that input. And then again, next user message gets received by the bot. We combine it with the updated state, predict the next action. All right, so this is the high-level view. Let's dive into the machine learning. So Rasa NLU does some intent classification into entity extraction. And we do have our recurrent neural network here in the middle that receives different types of input, right? It receives the intent classification results, it receives entity extraction results, it receives results from API calls. So if you fetch the weather API, that API might return, I don't know that location, or I'm currently unavailable. And all of these results should influence the prediction of the next action of the bot, right? If the API is not available, probably want to tell that the user that, right, currently there's no weather or something. And that model receives that data for every user message, right? So if we want to predict the next action, we don't only look at the current state, but also we look at all the past states. right? So the previous message of the user gets fed into this model first, and then our current state is get fed into our LSTM. So this is why it's a recurrent neural network model. It does not only handle one input, but multiple inputs after one another, which kind of have a relationship between them. Then usually what's implemented afterwards is an action mask. So sometimes you do have actions that require, for example, authentications. So for example, if your user can't change the address with your bot, you only want to allow that for users that actually are customers of your bank. And to really make sure your bot never predicts something that it should not execute, you do have your action mask and some conditions there. So this was described in the original paper. We have not implemented that in Rasa yet because we didn't need it yet. And then usually renormalize, right? So because you've excluded a couple actions, so to like allow your action predictions to sum up to 1 again, you just renormalize. And then you have probabilities for all actions that are possible. You just choose the most likely one when you use the bot, and doing training, you just sample from that distribution. And then that creates your next action, right? Which could either be an API call, or it can be user utterance, a bot utterance. And depending on the type, it will then return a message here. One important part is that this loop here, right? So this prediction loop between the model here and an action that gets executed down here can be repeated multiple times. So it's not always one user input and one bot action. It can also be one user input, 5 bot actions, and then we wait for the next user input. This allows you to like make your bot actions very small and then compose them in different dialogues in the way you want them. So for example, in our example, there is probably one action that fetches the data from the API and a second action that actually creates the user utterance. So in that case, we would have 2 actions. Actually, it's 3 because the last action we predict is action listen. So this is kind of a special action. Once we predict that, we wait for the next user input. So this is kind of our sign that tells us, okay, stop the prediction for now, wait for the next user input. Any questions? Yeah.
It's also trained on real dialects, real conversations?
It is trained on real conversations, yeah. I'll show you how we're going to create the training data. We're going to create it by hand and not like train it on real dialogues because we have not collected them yet. But the idea really is that you create your initial version of the bot, put it online, and then collect more and more dialogues. All right, creating this kind of improvement loop, right? Collecting more and more data, improving the bot, retraining it, putting it online. So this is the whole idea. And this is like the major benefit of using these trained models instead of full systems, right? Because you can base your new models on training data you collect from your users. And this is why it's really valuable that you actually own your own data. All right, that's good. Yeah, no, that's the next slide. Let me get to that notebook again. Okay, writing stories. So as we said, we do need a couple dialogues that our bot is trained on. And there's different ways to create like these initial stories our bot is trained on. I'll show you one way, and after that, once we're done, I'll show you quickly another way to create them. We do have a special formula for creating these stories, but it's really simple. So every story has a title for us humans to later understand what they mean. This is usually only used in initial data generation. So when you generate your data from user conversations, they don't have a title usually. So this is just like a simple greet. Right. So in this case, the user says greet. So this is the intent of the user message. Remember, we already extracted that using our NLU. And then we tell our bot to do utter greet. And that's about it. Right. So this is the incoming message. Then we want our bot to predict utter greet, and the next action it predicts afterwards is action listen. And this is the whole interaction. It's tough. Let's try and see if that works. And then we'll extend that. We do need a so-called domain file as well. So this defines the scope of the bot. It contains all the intents it handles, right? So these are the intents we trained our NLU on. Then we do have all the actions the bot can execute, right? So this is a closed list as well. You need to define them beforehand. In this case, it's just utterances, right? So we do have a couple of response templates here. Don't move that around. And the bot can predict to like respond with these messages to the user. Yeah?
How would you ever, so you, let's say the bot predicts action listen,
Mm-hmm.
how would it ever know to stop listening? Like you have those people that press enter after every utterance.
Yeah.
So how would it know when to stop listening and actually do something?
Mm-hmm. So, I mean, I think you do mean something else. But so action listen always stops when the user writes something new, right? As soon as the user writes something, shoots a message at the bot will start predicting again. Maybe what you mean is users that like split their messages into multiple parts. Yeah. So that is not too easy. What you can do is, and you should probably do that before sending the message to the bot, you can just wait for 1 or 2 seconds, right? Giving the user more time. Because it's hard to detect when the user is done with his typing, right? Some platforms will give you some indication, right? So they will tell you, okay, the user is still typing. In that case, you just collect the data and then process it as one message, for example. Or process it at multiple messages, but like as one large blob. Yeah, that's kind of the approach. Yeah. So best is obviously if the platform you're using provides you with some information if the user is still inputting stuff. Yeah. Okay, yeah, so we got our utter templates here, which are kind of the responses our bot is going to send back to the user. Now we're going to write them to our file. And yeah, we can actually visualize our training data, which is easy. So it's just greet, utter greet, and done. And let's train that really simple model here. And to do so, we're creating an agent. So this is how we call a bot that gets trained and is trained later on. And what you can see here is that we feed in our domain file, so kind of what our bot is supposed to handle, as well as a list of policies. And these policies really are just machine learning models, or in the case of the memorization policy, it's just a large list of remembered training data. And you can add more and more policies here. And we will add one more in a minute. And all of these policies kind of do this prediction, and then the one with the largest probability wins. So this is how we decided. You could also do different approaches there, selecting the most confident one, or the one that responds first, whatever you like. Then we load our training data here in our stories. And we'll train our bot for 400 epochs. As I've heard, you've learned a couple hours ago what that means. So we'll look at each training example 400 times, which is not, we don't have a lot of training data. We do have 6 examples that we're going to train our LSTM model on. Yeah, it reached accuracy 1. Yeah, what a surprise. So it is working, it trained a model, it persisted it. And what happened in the back here is that we created our Keras model, our LSTM. We created our training data from our stories, fed all that data into the machine learning model, into our TensorFlow model here that Keras is using, trained that on 400 epochs, and then persisted that on disk. Right, we're not going to use it just now because there's not really anything we can do with this bot. So let's make up my magic Sublime part and add a bit more training data. So what you can see here is that I now provide, let's say, 7 different dialogue examples instead of just 1. And here now we can see, okay, it's greet, then utter greet from the bot. Then the user says, okay, I'm already great. And the bot then responds, okay, he's happy as well. The user affirms, then we say happy as well. So it's a really simple bot, but as you can see, this is how we define our training data. And if the user responds with mood unhappy, as in this case, we will do something else, right? We will do utter cheer up instead of utter happy. It really depends on the context and the response from the user. So let's again write that to file and then visualize that. And as you can see, it's getting more complex. It's still a very simple use case, but as you can see, user can shoot different initial messages at our bot. You can directly say goodbye, and it's goodbye. Or you can start with greeting, and then the bot is greeting back. And then here's our actual fork we want to design around, right? Users happy or unhappy. And depending on that, we do different dialog paths. Or you can see interesting things like that one, like the mood affirm and the utter happy. So you can actually infinitely many times say mood affirm. Yeah.
This is already predefined, and what is it actually still learning?
This, okay, that's a very good question. So this is not the trained model. This is just visualizing the training data. This is just showing us what the training data looks like. So which kind of different dialog paths are persisted in that training data file. It's not the actual model. Yeah. But you could actually do something similar with the trained model, like kind of feeding the training data into the model, seeing what it predicts, and then like drawing it in that similar way. But right now, this is really just visualizing training data.
Know when I have this
Yeah.
event, I should always answer this.
Mhm.
You can just hard code that basically.
Yeah, exactly. Then you could build a state machine out of that. This is true. But then again, there are cases in here that are not handled, right? So for example, the bot says utter happy in this case, and now the user says mood deny, for example. It's not mapped in that state machine here. And you will always have these cases, right? And you will have more and more cases the larger your domain gets and the more complex your problem gets. Yeah, so this is really just a training data visualization. I'll train the same model for again 400 epochs. Wait. Okay, done. Okay, now we can actually load our model. Because now I want to actually chat with our bot and see if it actually learned these stories we've told it. And this command is going to load our language model, right, as an interpreter from the model directory that we've used to persist our initial language model. And it's going to load our dialogue model as well. And then we have this little snippet that allows us, so this is kind of my chat window now. It's like a pretty rudimentary way of inputting and chatting with my bot. And it's not as cool as Facebook because it cannot show me any images, but it works at least. Right, so I can now send messages and I'll get answers from the bot. So you can say, hi, how are you? I'm great. Great, carry on. All right, let's say hi again. How are you? All right, so let's try that first, and then we'll do our pizza and Hawaii stuff. So I'm not so well, so now it's trying to lighten my mood and asking me, did that help? Yes. Great, carry on, right? So we can see that bot learned to like reproduce the training data it has learned. And yeah, we can put in pizza here, and it will say, how are you? I can do it again. It'll say, how are you? Yeah, interesting move. So in that case, it probably recognized that as something like I'm not so well or something like that, and tries to lighten my mood. Yeah, but what if the bot doesn't get what the message means? So let's try to handle that. And we can actually do that. to some extent. So as I said, it's a hard problem to handle these out-of-scope messages. But one good indication is the confidence we get back from the classifier. Right? It depends on the model, and some models aren't well calibrated. But the more data you have, usually helps there. So let me add that here. So what we're going to do is we're going to create a fallback policy, which basically says if the intent confidence is too low or if the action confidence is too low, stop predicting or stop doing what you want to do. And instead use a predefined action. And we do have one that does exactly fit that case, which is utter unclear, right? So kind of if we don't get exactly what the user means, we're gonna utter unclear. Up right there, so let's put that in here, utter unclear. And we also need to put in some thresholds that we're going to use. So these are kind of probabilities. So if the prediction probability from the models is below that value, then we're going to use our fallback. And we do have one for NLU as well. And I tried it, 0.6. No, 6. Random values. No question. Okay. Maybe the question might be, how do you get these values? Which is a really good question. And one good way to do it is take a look at your NLU training data for the NLU threshold. What we've done in the past is kind of use your test data, let your model predict on that test data, collect all the confidences, and then based on that, plot these confidences, see where kind of the threshold is for wrong predictions, correct predictions. That gives you good indication of what threshold you can use there. I didn't do that. I just picked it randomly. Yeah, if you get stuck, that usually means that this input window is still open and you need to type stop here. Because otherwise it will not execute the other fields of the Python notebook. Because we do have our cool while true loop here. Okay, so let's see. Okay, so a new model is created and trained. Running a bit of time. Okay, let's see again. Okay, still works. Okay, hi, how are you? I'm great. Okay, still works. Let's see what pizza does. Pizza doesn't work. Boy. Let's see why that is. I thought the confidence is below that, but we can try that out here. Pizza. Where are you? Okay, confidence is actually lower than that. Oh, yeah. Oh, this. Ah, yeah, poor me. So I did create my policy, but I did not add it to the list. So let's do that and try again. Yeah. So actually that fallback policy doesn't need any training, but it still gets persisted as part of the model. And if you want to load the model with the fallback policy, we need to retrain it.
Do you do any auto tuning here? Like
So
of training your LSTM?
what do you mean for audio, like hyperparameter search or? Good question.
It seems so like if you use
No.
insert any data and any model, then
Yeah.
like, there might be some parameter tuning involved.
Yeah. So we don't do it for the LSTM. We, for example, do it for the SVM for NLU classification. For the Keras models, we usually don't do that because they already train kind of quite long. and it depends on your resources. So you'd usually do that in a script that is kind of separate from Rasa Core, which you could do, just start it, collect results, start again. Because you can actually define these parameters in the configuration. So we can take a quick look. So this is the persisted model here, the persisted model folder. And we can look at, for example, right here, this is the persisted NLU model, and you can see here the parameters that model get trained on. So this, for example, did a hyperparameter search for the SVM on these parameters. These are the default parameters. You could change them and then kind of experiment with your parameters. Yeah. All right, so model trained, persisted. Let's load that. And let me quickly check the time. 15?
You have plenty of time.
I have plenty of time. That's good. All right. Let's try that. Hey, still works? Pizza? Doesn't work. Why? Doesn't work. Okay, so this is kind of one way to handle it. But as I said, it's not easy to get like these threshold, and you should. It's better to train your NLU model already to like handle these out of scope messages. But this is one additional fallback that you can use to get a sane bot. Okay, there's one more thing I want to show, which is, but how do I execute custom code? Because what we've seen just now is just uttering back messages, but what I actually want to do is run some custom code. Oh, I already wrote it. Yeah, that's good. I'm going to save some time here. Partially wrote it. So we're going to create our custom action, right? It needs to be a subclass of action. It needs to have a name and needs to have a run method, and that's it, right? So the name is going to be used in our training data, in our stories, right? So this is the name we use to reference that action. And our run method is getting executed once our bot predicts that action. So we can actually utter a message here back to the bot, to the user, searching for image, whatever. And then we can fetch the image from one possible source of random images. Pick some photos slash 200, 300 slash random. No, not done. Okay. Right, so this is kind of, I could do anything in this action right now. I can call any APIs, can connect to databases. You could also download the image right here. I'm just gonna not do a web request right now, but I'm gonna do a so-called slot set event. Each action can emit a couple events that modify the dialog state. So this is used to let your API results influence your dialog predictions. This is used to kind of restart the dialog, to pause the dialog. For example, if you have a system where a human can take over the conversation and you want to pause the bot, and your action can actually do that by emitting these events in its run method. And we're going to set the slot called image API response. We're going to set it to our URL. We could also fetch, as I said, the image here and use it that way. Is that correct? Okay, that works. We still need to define that slot in our domain. So this is something additionally we need to do. So slots, let's add it here. Where do I have that? Yeah. Image API response, and that has a type and unfeatureized. So each slot can have a type. So slots are kind of structured memory of the bot. You can have slots for the name of the user, for its birthday, for API results, all of that. And in our case, this slot should not influence the dialog prediction, right? So it doesn't matter if it's set or not, dialog will behave the same way. You could also use text here, for example, and in that case, it actually makes a difference if the slot contains a value or not. Or you can also use float here, and then we'll actually use that float and push it through to the machine learning model. So your slots can really influence the prediction here. But for our use case, we don't need that. And then in our cheer app, we're going to use that slot value. So we do have some simple templating here for generating the responses for these simple cases. Okay, should be good. One more thing. I also need to add my action to the list of available actions. And because I'm in so usually you need to specify the module path here, but in IPython that's just main. Call API. So we have added our action, we've added our slots, but our bot will still never predict it because it's not part of the training data. So that action we have down here is never referenced in our stories. So let's quickly do that. After unhappy, we first want to do a call API, and we do have that here as well. Okay, so updated our stories. Let's train again. That did not work. Call image API. Yep. Oh, it looks better. Hopefully. Yeah, it really doesn't need to be trained for 400 epochs, I guess. Yeah, but now it's done anyways. So, okay, so this is the way to customize like what your bot executes, and it really allows you to execute custom code. We're currently thinking about making that easy to be used from other languages as well. So kind of writing, training your bot in Python, running it as a server, but having your actual logic in JavaScript, right? Calling actions over HTTP and just executing them in different programming language. All right, that's right. Hey, how are you? Not so good. Yeah, none. Yeah, that didn't work. Good point. None. Okay, none is the initial value. It's good. Why? Why? Okay. Yeah. No, I'm not going to lose too much time. I'm going to figure that out later. Why it's not doing that. Might not be retrained properly. Yeah, it should actually work. But, yeah. You can view the actual executed proper notebook where I didn't code, but did it beforehand, so that works in there. Not sure what went wrong there. And we can actually evaluate our dialogues quite similar to our NLU evaluation and just see, okay, how are the predictions performing? Are there any actions in there that don't get predicted? So this actually looks good. Is our custom image API actions in there as well? Okay, I don't know. Yeah, not sure what went wrong there. That's odd. Okay, I'll look that up later. Okay, so let's go back. How much time do I still have?
So the bugger off is at the moment stuck in the train because of our great transport system. So you've got some time.
Yeah. More body move exercises for you.
Okay.
All right. that leaves me enough time to show another way to train the bot. So as I said, writing these stories doesn't always work, as you've just seen, right? It can fail. And there's a different way to train your bot, which is from actual conversations, even if you create your bot initially. So kind of the user says something, bot does something stupid, you correct that behavior, retrain the model, and hopefully afterwards your bot performs well. So let me show you how that works in the command line. There we go. I've created a make file in that repository I showed you earlier that contains like all of these commands. They kind of call Rasa Core, and I'm a bit lazy, so I'm just going to use that interactive command here. That is not available here. That is true. So let's remove that. It's a bit of an issue because now I'm running on the command line, so that action is not in scope anymore in main, which is kind of an issue just here. So let's remove that for the time being. And just go with our original version. Okay, let's try again. Okay, what happens here is the bot will still be trained on our initial stories, right? But that file could have also been empty. That doesn't really matter. Because the idea here is that we refine the bot while talking to it. So it will tell us what it recognized, it will tell us which actions it predicted, and then we can always decide is that correct or wrong. And this is just a simple example on the command line, but this is like how I imagine training a bot in the future. Not necessarily on the command line, because you would really need some UI here. So I typed hey, so the bot recognized that I said hey. It got the correct intent here. It now wants to do utter greet, which is correct, right? So I can say that's correct. Now the bot uttered, hey, how are you? And now wants to listen, right? Sounds good as well. Now I can say, great. No, what do I say? Great. Great sounds good. Let's say great. And now maybe I don't want to do utter happy, right? But the intent is correct, but I want to do execute a different action, so kind of option 2. And now I can see here the probabilities the model predicted. As you can see, the model really overfit the training data very well. So let's make sure it doesn't do that anymore, because now we're adding some conflicting data there. I want to cheer the bot to cheer me up anyways. So let's tell the bot to do that. So it executed that action now predicting action listen again, which is not correct because it should ask me if that helps. As you can see, it's starting to get a bit unsure about itself. So now it wants to listen again, correct, user input. Did that help? Yes, that helped. And now bot says utter happy, which is correct. But as you can see, this allows you to kind of, while chatting with the bot, modify its behavior and kind of train it. And let's say action listen. Next input maybe awesome. I'm not sure where I am in the conversation just now because of me talking. But you can then export that conversation as well. Kind of use it as additional stories. And then we can just take a quick look at that file. And then we can see it just created similar stories to what we've written in file. And just from conversations I had with the bot. And now you can imagine, okay, multiple users having chats with the bot, you recognize when the bot fails, and then you retrain it. Writing these kinds of stories is still easy, but during the training, the actions aren't actually executed. But since they can influence the training by setting slots, you need that as part of your training data as well. So if I want the bot to actually care about a slot that let's say we do have our API action here, call image API, and that action now sets a slot like we did in our image response, some URL random. As you can see here, if I want that slot to influence the prediction, I need to put it in the training data. And if you get more and more slots, that gets harder writing by hand, and this is why like this interactive mode or learning directly from your user's data is better than like creating this from hand, because it gets difficult quite quickly. All right, let's wrap that up. Research. We're currently looking at NLU and creating embeddings there. I mentioned that earlier. We have really cool blog posts about that, and the idea here is that it allows you to do multi-intent labels. It allows you to recognize similarities between labels. For example, that the question, I'm looking for a restaurant and I'm looking for a hotel, are quite similar in a sense grammatically as well as word choice. So these intents are similar, whether on the other hand, like greet and goodbye are maybe more dissimilar. And all of that is based on a star space paper, which is a really good paper that Facebook published there. And here we can see some strange examples we created for that. So users can combine stuff, and then you'll get multiple intents and can handle these multi-intent cases as well in your dialog system. Obviously, makes things a lot more complex, but again, right, you can collect the training data and modify that later on if you really want your bot to handle these cases. All right, I'm going to skip through that a bit, but as I said, there's a lot of resources from on our blog post that you can use to really get into details here. We're also looking at new dialogue models, right, making the training there even better. And here's one example from a paper that's hopefully getting published and accepted. We'll see. And we've created a new embedding scheme here, which is also based on star space, so a similar model, but using a neural Turing machine there in the middle. So if you're interested in that, there's going to be a paper about that pretty soon. And why do we do that? So why do we create new models? We want to generalize better between domains, right? So I've showed you how to create training data for one domain. Now you can go collect more training data for your domain. But what if you created a great bot for hotel reservations, and now you want to expand that bot to restaurant reservations, right? It would be good to like reuse some knowledge from the one domain for the other domain. And as long as they share some information, like what you want to know from the user, actually you can share that information between the stories. And this is what our new models allow you to do. Okay, since I'm already a bit over time, I'm not going to go into the extensions in detail, but you can combine these machine learning models with rule-based systems, right? For some things, rule-based systems are really good, right? For example, for normalization, as I said. For a rule-based system, it's really easy to say, okay, tomorrow, what's the current date? Okay, this is the ISA date. We can take a quick look at the duckling patterns. What they implemented here is basically just a large regex parsing system. So here's a regex for half an hour, which is 1.5 an hour, half an hour, whatever. And that creates 30 minutes, right? And there are a lot of these different regular expressions here to convert certain expressions into structured information. And for some entities, that really is useful. And it's really good to combine that with your machine learning. Where's my presentation? There we go. Yeah, it's not full screen anymore. Great. Doesn't matter. Yeah, we've seen the spacey built-in models, so it's also good to like rely on these built-in models. And we also provide some functionality to do form filling, right? So this is a really common task we've seen. how many people do you need for your restaurant table, when do you want to book it, like these slot filling tasks where you have certain pieces of information that you need before you can actually submit that information to your API. And we've integrated that form filling part in Rasa to make that easier. Okay, some final thoughts before I close up. I made that point a couple of times during the talk. What we want to achieve is really that you're able to retrain the bot based on new data, which is that big benefit of using machine learning instead of rule-based system. So new data comes in, you correct that training data, right? Create new NLU annotations, create new dialogue stories, retrain your models, relabel your collected data, right? Let's say you've collected 1,000 messages from users, you've retrained your models, you want to relabel them to then see, okay, which of them are still wrong. And then you can use that improved model to continuously improve your bot. There's still a lot of open challenges, right? We've talked about them handling out of vocabulary words, so words that you don't have any word vectors for, or multi-language entity recognition, right? So these models are usually trained on a single language or combining multiple dialogue models from different domains. How do you decide which dialogue model is able to handle next message? All that stuff. All right. You'll get the slides. So there's a couple of good reads for a rainy day. First one's really good. It's from Manning, who's really famous for natural language processing, and he's like comparing, okay, how does deep learning fit into the natural language processing domain, which is like more into this feature creation and finding out best features for machine learning models. And all of these are very interesting reads. So take some time there. So four take-home thoughts. Really important are techniques to handle small data sets, because you'll start small when creating a new bot, right? You don't have a lot of data, and really providing models for that can handle that is really essential. But then once you've collected more and more data, you want to scale these models and create better models that actually can handle the complexity of your dialogues. And it's always good to combine that with traditional programming and rules, right? We haven't done that in our example, but as I said, right, you don't need to rely on machine learning for everything, and should really go back to traditional programming where necessary, right? There are end-to-end models, for example, that also predict API calls, right, and the parameters for that, but it's really difficult and you need a lot of training data for that. So just avoid that where possible. And abandon flowcharts, of course. Just for showing your training data, it's good, but for everything else, it's not so good. Yeah, thanks a lot for your attention, for your participation, and yeah, hope to see you around.